Now, often a question like this is asked. Titanium dioxide and zinc sulfate. Titanium dioxide and zinc sulfate both are colorless. But titanium and zinc will come under transition elements, D block elements. But usually we say the compounds of transition elements are colored. But zinc sulfate, titanium dioxide, these two compounds, even though they come under D block elements, they are white, colorless. Now, what is the reason? Now, let us relate this question with another question, because the answer is going to be the same. Why are transition metal compounds are colored? So the questions may be framed in these fashions. We can ask why some compounds are colorless, and we can also ask the same question in this fashion, why these compounds are colored. Now, the explanation is D transition. For the transition metal compounds are to be colored, the reason is there should be what is called D transition. Electrons are transferred from one set of D to another set of D. So, this point you should remember, namely, wherever D transition is possible, there will be definitely a color for that particular compound. All right. When does this D transition possible? This is another question. You say if D transition is possible, there will be a color. But when does this D transition possible? D transition is possible only if incomplete D electrons are incomplete in the sense no D0 configuration, no D10 configuration. That is, if there is no electron in the D orbital, D transition is not possible. If D10 configuration is present, then also, because D orbital's maximum number of electrons will be 10. So, completely filled D orbital, this configuration, and D0 configuration, in these two cases, there will not be any D transition. If there is no D transition, then we say that particular compound is colorless. So, if a question is asked whether these compounds are colored, why, or some of the compounds of transition metal ions are colorless, for all these the same answer. Whenever there is a D transition possible, then there is color. It is definite. We can ask another question. A question like this is asked. All right, manganese is one of the transition metals. We know an important compound of manganese, potassium permanganate, a pink colored solution. Potassium permanganate is a pink colored compound, but if you consider manganese in that particular compound, it is in +7 state. Manganese in +7 state means there is no D electron available in potassium permanganate for Mn +7 state. D0 configuration. D0 configuration means there should not be DD transition. If there is no DD transition, the substance should be colorless. But potassium permanganate is colored. Why? This question may be asked. In the problems just we have seen, I have told you, if there is a DD transition, there is color. If there is no DD transition, as in the case of D0 or D10, the compound is colorless. But potassium permanganate M1 plus 7 has the configuration D0, but the compound KMnO4 is colored. If there is no DD transition, how is it that potassium permanganate is colored? Now it has been observed, DD transition alone is not responsible for color. There is another explanation, what is called charge transfer spectra. In the case of potassium permanganate, we notice there is no DD transition. If it is so, the compound should be colorless. But the compound is colored. What is the reason for it? The reason is charge transfer spectra is the reason for the color of potassium permanganate, even though there is no DD